Hey everyone, welcome back to MP Coding. In this video, we're going to talk about something super important before we write even a single line of driver code. How Linux actually organizes everything on any hardware, the kernel, and your normal programs. Imagine three clear layers stacked on top of each other. At the very bottom is the real hardware. Processor, the memory chips, the GPIO pins, the I2C and SPI controllers, the UART for serial, all the physical stuff you can touch. Your programs, the Python scripts, the C apps, the terminal commands, they never get to touch this hardware directly. That would be dangerous and messy. Instead, everything goes through the Linux kernel, which sits in the middle layer. We call this middle layer kernel space. The kernel runs in a special privileged mode, which means it can do anything. It can read or write any memory address. It can talk straight to the hardware registers. It can stop or start any program. This is exactly where our device drivers will live. Above the kernel we have user space. That's where all your normal applications run. User space is deliberately locked down. It can only see virtual memory, not the real physical addresses. If a program in user space tries to poke the GPIO registers directly, the processor stops it immediately and the program crashes with a segmentation fault. That protection is there for a reason. One buggy program shouldn't be able to crash the whole system or mess up another program's data. Instead, Linux puts a smart middle layer called the hardware abstraction layer, or HAL for short, right inside the kernel. This layer hides the exact details of the silicon and gives every driver a clean, stable way to talk to the hardware, no matter if you're on a Pi 4, Pi 5, or another ARM board. So how do your applications actually control the hardware? Through device drivers. Drivers are small pieces of code that live inside the kernel. They are the only ones allowed to talk to the real hardware, and they expose simple, safe interfaces to user space. Things like opening /dev/mydevice, reading, writing, or using IO control commands. Your user program stays nice and simple, and all the complicated low-level stuff stays safely inside the kernel. This separation also makes your code portable. If you write a proper driver, the same code will work on a Raspberry Pi 4, a Pi 5, or even a different ARM board, even if the hardware changed a bit underneath, because the kernel and the driver hide those details. That's why, before we start writing any driver, it's really useful to have this picture clear in your head. Hardware layer in the bottom, kernel space lives in the middle, and the user space lives in the top. Keep that image in mind, because in the next videos we'll start building those drivers that sit right in the middle and safely connect your applications to the real Raspberry Pi hardware. That's it for today. Short and simple, but super important. In the next video we'll finish the preparation part of the Raspberry Pi. See you there.